Good day, students. Today we're going to look at some more exercises. We're dealing with logarithms. This is number 5 on page 125 of practice 1 in chapter 5, book 2, ma1026. Now, as you can see in number 5, we're asked to write as a sum or difference of logarithms without exponents. Okay? So we're trying to separate them into separate logs. Now, if we look at the number 35, you have choices here, so answers will vary, but the most common factors, if we were looking to break down 35, most people would use 5 times 7. So the first thing you do is try to write it as a product or as a division statement. So we could, I think the simplest one to use here would be 5 times 7, the most common product. Now we could have changed it to anything we want. We could have said log base 9 of 70 divided by 2. Right? That's also 35. Or so there's different answers here for these. I'm going to leave it as 5 times 7. Right? So then, of course, we go the next step, which is to write it as a sum. Because it's multiplication, I can split that into separate logs now. Log base 9 of 5, and because it's multiplied, plus log base 9 of 7. Now, no exponents here, so no, I have nothing to move down or up in this case. See, there's no exponent right here, so I have nothing to move down. Well, there is an exponent. It's understood to be 1. However, other than 1, there's not. So that would be your final answer there for that one. And again, answers vary depending on what numbers you decide to use. Okay, the second one has a division statement already there. So we can separate that, of course, using the subtraction rule, right? Division is the same as subtraction. So if you have a quotient, right, and we just change that to subtraction like that. Very simple one, isn't it? No exponents to move. Alright, the next one, well, that cube there is just on the t, right? So we're just going to separate, but that's 5 times. So there's times in between here, right? That's 5 times t squared. So we'll use the product rule, which means we can change it to log base 4 of 5 plus, okay, log base 4 of t cubed. Now don't forget the instructions say without exponents. Okay, so what does that mean? That means this exponent has to be moved back down in front, okay, as a coefficient, which is this, in which you know as the power rule of logs, right? Okay, so our final answer for this one will be log base 4 of 5 plus log base 4 of t with the 3 moved down in front. See that? Let me just write that again. Okay, so one more time. See how I did it? So the log base 4 of 5 plus, and move the 3 down in front. So I should have wrote that first. Log base 4 of t. Now we have written it as a sum without exponents. Okay. Now the next one, again, you can do in 2 stages. You can do in 1 step. Depends how competent you are now with these. So this will be log base 2 of, because it's division, I'm going to say PQ subtract log base 2 of R. But then I can break this one up because it's multiply in between. I can break this one up to be log base 2 of P plus log base 2 of Q minus log base 2 of R. So there's the answer for that one. I think you're getting the idea now, hopefully. So what do we have here now? We got log base 2 of x cubed subtract, right, because it's division, we do the subtraction, log base 2 of y squared. Now again, it's without exponents, so we have to move the exponents. Both of these have to be moved down. This one has to be moved down. This one has to be moved in front as a coefficient. Okay, so we end up with 3 log base 2 of x subtract 2 log base 2 of y. And that's the answer to E and F. Now notice we have a 5 already outside the bracket. See the difference between this one and this one? The exponents here were inside the bracket, right on the x cubed and y, right on the y squared. Here, the 5 is outside. So you get a couple of choices here, but I think what I'll do quickly is move that down. So it'll be 5 log base 2 of x over y. And then that would be 5 log 2 of x minus log base 2 of y, but that's brackets around them because the 5 is in front. Let me change to a different color. And one last step, multiply by 5 both of these. It'll be log base 2 of x subtract 5 log base 2 of y. Because see how we did that? So because this number is out front of the log, before you change it to subtraction, you had to multiply by both. Okay? So there you have some solutions for you. This is on page, again, 125, number 5.